Welcome back to part 2. We're picking up where we left off in part 1, replacing the 2 capacitors in this filter can. Be sure to subscribe and click on the bell icon to be notified of future videos. With this rubber sleeve on here, this outer coating, I'd rather use the knife on that as opposed to a stripper. Not that I need to protect this. I think more to secure maybe the connection. I'm going to put some heat shrink on these tabs. Let's get the hot air gun out here as opposed to using a lighter on that. What I'm going to do is hot glue this. Now both of these are glued in. Now for some reason I didn't record the final process of this cap. But if you can look inside of here, what I did was I cut out a cardboard ring with an inner circle. I placed it over this cap, and then I put the metal retaining ring along the outside. I hot glued 2 sides of this. I didn't hot glue the cap to the bottom. That way somebody can actually pull this out to repair it at a later date. And then I put some hot glue on these 2 leads, then ran the wires out, and we'll begin hooking them back up. So let's try cleaning this up here before I solder this on. Now I know that these should be twisted together, but working with 2 different types of wire, a solid and a stranded, it becomes a little bit difficult to do that. So we'll rely on the solder and the heat shrink. This will be in the case, so there won't be any stress on it. Okay, let's hook the rectifier back up. Okay, what we're going to do is hook this up to the variac. We'll put the power switch on and we'll slowly bring this up. Okay, we're at 40 volts here. Well, as I was slowly starting to bring this up on the variac, I noticed that the voltages just weren't right. You know, something was just acting wrong. So I shut it off and I felt the rectifier and it was extremely warm. So I pulled it out and let's measure it. I'm on the diode setting. Let's go across one diode here. That's a short. That's a short. That's a short. A short. That junction looks okay. That junction looks okay. So it looks like this bridge, this diode here and this diode here are bad. Let's check it one more place. Now we said these two were bad, so let's check them. Ah, a resistor. Okay. This was the other one that showed bad. A resistor. So now let's check the ones that ohmed out good. A diode. And a diode. That probably happened when somebody turned this on with this bad cap because we had a blown fuse in here. But being the size, I can't come up with a number on here. But I'm assuming that that is probably at least a 20 amp rectifier. I am concerned now about the variac. So what I'm going to do is I'm going to hook up to the AC input to the rectifier. And we'll hook it up to the meter. The variac is set for 60 volts right now, and I'm on 0 on the variac of the power supply, and I'm bringing this up. Okay, power switch on. "12 volts at maximum." Let's keep bringing this AC input up. We're at 80 volts. We're at 100 volts. We're at 120 volts. If I adjust the power supply variac, that's fully left hand at 0.6 volts, and fully clockwise is 24 volts. So I'm going to let that run for just a second. I want to see if the transformer gets warm or I smell anything. Okay, AC is off to it. And the transformer feels just as cold as can be. The next step I'm going to do is I will put 24 volts, the input, that will simulate the output of the bridge rectifier. And we're going to hook this up to the output of the power supply. We're going to be monitoring DC volts, and we're going to be bringing it up. This is where I noticed a problem on the meter. The black wire, the ground wire from the caps, is hooked to the yellow wire, and the yellow wire is the positive of the output of the power supply. And the ground of the unit is hooked to one of the positives of the filter capacitors. If I wouldn't have made the checks prior to hooking this up to AC with the new bridge rectifier, I would have severely damaged the unit. So let's repair my mistake and try this test over again. Okay, after fixing my wiring screw up, and before I do this voltage test, I thought I would go ahead and adjust the meter to read 0 volts. There we go. Looks like my current might be a little bit high. Let's adjust that as well. we go. Okay, let me clean the covers and put the covers back on. Okay, so my DC volts is 0 coming in. I'm going to be raising my input. Okay, I'm at 5 volts DC in. I'm at 20 volts. I'm at 30 volts. I'm at 40 volts. For full scale on this, at 20 volts on this meter, it looks like I am at 42 volts input. My meter itself on the output says 21.6 volts. Pretty close. Okay, we're ready for the new bridge rectifier. Well, the new bridge rectifier has come in. We'll go ahead and get that installed. But looking at it, I noticed that there are some tape marks here. I don't remember ever doing it. It's possible that this is a different unit than the unit that I had been using. I think I've got 3 or 4 of these. So let's take care of this tape mark first, and then we'll go ahead and install the bridge rectifier. Okay, we have the tape removed and the new heat shrink on. So now looking at it, we have AC and plus. So it's going to be AC, AC, plus, minus. Okay, our 2 ACs. And our DC. And I think, since this is loose in here, I think what I'd like to do is affix that to the case. There is no mounting brackets on here. So let's hot glue it on. Okay, what I've done is I've hooked up the meter to the output of the bridge rectifier. I've got the Eico hooked up to the variac, and we're going to slowly be bringing this up, monitoring the output of the bridge rectifier, and we'll be watching the DC voltage on the Eico. So we're going to start bringing this up. Okay, we're at 120 volts. Okay, I turned everything off to measure the heat. And it seems just fine. Now we're measuring the output compared to the meter. We turn the variac down again. Eico is on. Variac is on. Okay, we're at 120 volts. We're measuring 22 volts here. The meter here is reading 20 volts. So let's take this down. And we'll take it to the marking of 12 volts. We're at 12 volts here. And let's take it down more. We'll take it to 6 volts. Actually, let's take it to 5. That's about 5 volts. Yes, it is 5 volts. So let's change it to the 6 volt scale. We're at 6 volts here. And that should be 12 volts. 13 volts. Okay, looks good. Now let's hook a load up to this and see what happens. Okay, I have two old 5 ohm resistors here in series. That would be a total of 10 ohms. Okay, variac is on. Power supply is on. Let's bring this up to 10 volts. 10 volts at 10 ohms should be 1 amp. And we're at 1 amp. So let's take this up to 20. Oops, we're on 12 volts here. Okay, we're at 20, and that's 2 amps. So this unit is done. All we need to do is clean it up, put it back into the case, and we're ready to put it on the service. Okay, there we have it. An Eico 1064, ready to go back onto the workbench. If you found this video useful or entertaining, Please subscribe. Give me a thumbs up and don't forget to click on the bell icon to be notified of upcoming videos. Stay safe, stay healthy, and thanks for watching.